How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for ways of expressing concentration. So number one, what is the molality of a 25.4% by mass aqueous solution of phosphoric acid? So whenever you got percentages, remember that's percent for every 100. So if you just said, hey, you know what? I got 100 grams. I got a 100 gram sample. That means I have 25.4 grams of H3PO4, and then the rest of it is water. So 100 minus 25.4, I don't know, it gives me like 74.6 or something grams of H2O. So now it says, what is the molality? Well, the molality is the moles of solute per kilogram of solvent. So I already got my grams of solvent, so I could easily get kilograms of that. Divide by 1,000, I get 0.0746 kilograms of H2O. But now I need to get moles of my solute. So I might have to do a little math for that. Right, I have 25.4 grams times, well, how many, I got 1 mole, is how many grams for H3PO4? I wrote it down. Some off-screen movie magic. I think it's like 98.0 grams. When I do that math, I end up with 0.259 moles. Now I got moles, I can plug it in. I got 0.259 moles divided by kilograms of my solvent, 0.0746 kilograms. And when I plug and chug and bebop, bebop, boop, I get 3.47 molal as my final answer. All right, so whenever you got a percentage, you can assume you have 100 grams. Say, hey, for every 100 grams, it's this many grams of that, etc. All right, number two, what is the mole fraction of phosphoric acid in a 25.4 mass percent aqueous solution? So same kind of solution, but we want to express a different concentration, mole fraction. X, the mole fraction of H3PO4, is going to equal the moles of H3PO4 over the total moles. So it's going to be moles of H3PO4 and the moles of H2O, right? So they're going to be together in the denominator. So, assume 100 grams again. That means I got 25.4 grams of H3PO4. And if I do my math to convert that to moles, I divide by the GFM, and I did that off screen already. I get 0.259 moles of H3PO4. Now I got to do the same process for H2O. Well, H2O, the rest of it was H2O, so I have 74.6 grams of H2O divided by the molar mass of 18.02 grams per mole. Will tell me how many moles of water I have. So when I do that, I end up with 4.14 moles of H2O. So now my mole fraction is going to be that 0.259 divided by those two numbers added together. So 0.259 plus 4.14. And when I do that, what do I got? I get 0.0589. And that will be my mole fraction for H3PO4. All right, number three, a solution is 10% by mass of hydrochloric acid. What additional information do you need in order to calculate the molarity? Well, let's see. I got percent. So I know my grams of HCl over grams of solution times 100. I want to get molarity. So I need moles of HCl divided by liters of solution. Oh, wait a minute. All right, so if I got grams, I can get moles pretty easy using the GFM. But if I'm trying to convert grams of solution to liters of solution, I'm going to need my density. So there's no way to get the liters of solution without the density. So I need the density. Number four, what is the molality of a 17.5% by mass aqueous solution of nitric acid? So first you got to go, hey, well, what the heck is nitric acid? If it was 8 nitric acid, then it used to be ic. So it used to be nitrate and H in front. So there we go. That's what the compound is. It has a gram formula mass of 63.01 grams per mole. Now we go, all right, if I had 17.5% by mass, if I had 100 grams, I'd have 17.5 grams of HNO3, which means the rest of it, the 82.5 grams, is H2O. I'm trying to get molality. That's moles of my solute divided by kilograms of my solvent. So I got to convert 17.5 grams of HNO3 to moles. So I go 17.5 grams times 63.01 grams under 1 mole. When I do that, I get a number, 0.278 moles of HNO3. Now this 82.5 grams of H2O, I got to convert to kilograms, which is pretty straightforward. So kilograms, that would be divided by 1,000, 0.0825 kilograms in the denominator and 0.278 moles up top. So when I plug and chug and do this, I end up with 3.37 molal as my final answer. All right, 5. What is the molarity of a solution created by dissolving 15 grams of NH3 in 250 grams of water? The density of the resulting solution is 0.974 grams. So, all right, I need molarity. So if I want my molarity, I need moles of my solute divided by liters of solution. All right, well, my solute is NH3, and I got 15 grams of it. So let me figure that out first. Moles of NH3 is going to be equal to the grams divided by the GFM, gram formula mass. So I got 15 grams divided by the GFM of NH3, which is so like 17.03 grams per mole. And you know what? I might just even leave it like that. No, I'll do it. All right, so when you do that, you get 0.881 moles. Now my liters of solution, well, I know they told me the density, so I might need to use that. Density is mass over volume. But, all right, my mass, well, what am I trying? I'm trying to get volume. So let me rearrange. I get volume equals mass divided by density. Now the mass of the solution is 15 plus 250, so it's really 265 grams of solution, and they tell me the density is 0.974 grams per mole, or I'm sorry, grams per milliliter. So when I do that, I end up with 272 milliliters. So I got my moles. I need liters of solution, so let me convert this 272 milliliters to liters, 0.272 liters. So now I can just plug and chug and go, all right, well, my molarity is 0.881 moles divided by 0.272 liters of solution, and I end up with 3.24 molar. Capital M as my final answer. All right, number 6. What is the concentration of the chloride ion in molarity in a solution prepared by dissolving 23.7 grams of calcium chloride in 375 grams of water? The density of the resulting solution is 1.05 grams per milliliter. So similar problem. They want the concentration of the chloride ion. So let's start there. I got calcium chloride going to break up into the Ca plus 2 and 2 chloride ions. So I'm going to need to double whatever my concentration is of CaCl2 by 2, because I get twice as many chloride ions for every CaCl2. So molarity, moles of solute per liters of solution. So my solute is CaCl2. I got 23.7 grams of that. Let me start with that. Moles of CaCl2 is going to be equal to the grams, 23.7 grams divided by the GFM. of calcium chloride, which I did off screen, and it's 110.98 grams per mole. And when I do that math, I end up with 0.214 moles of CaCl2. So now I got my moles. Now I need my liters of solution. So again, my density is mass over volume. If I want volume, it's going to be volume equals mass over density. Now the mass has to be of the mixture. So I added 23.7 grams to 375 grams. So my total mass is going to be 398.7 grams because I add them together, divided by the density of 1.05 grams per milliliter. When I do that math, I end up with 380 milliliters, but I kind of convert that to liters. So I just divide by 1,000, I end up with 0.380 liters. So now I can plug all that into my molarity formula. I got 0.214 moles divided by 0.380 liters of solution. And when I do that, I get 0.562 molar. For that calcium chloride. But the problem is saying just the chloride ion. So I got to times that by, well, I get 2 chloride ions for every calcium chloride. So when I double that, I end up with 1.12 molar as my final answer. Cool. Last problem in the set. What is the molal concentration of HCl in a solution that is prepared by dissolving 5.5 grams in 200 grams of C2H6O? So molal is the moles of solute divided by kilograms of solvent. So I need to know how many moles is this 5.5 grams. 5.5 grams of HCl times by, well, 1 mole is 36.46 grams. Oh, you know what? Let me just leave that. All right, so my moles is going to be this 5.5 grams, and instead of having an in-between number, I'm just going to do it, set it all up. 36.4 6, I'm sorry, I forgot that number, grams per mole. That'll give me my moles divided by kilograms of solvent, which is 0.200 kilograms. And when I do that, I end up with 0.75 molal as my final answer. All right, I hope you found it helpful. See you in class. Goodbye.